Hi everyone, welcome back. We will continue from our last video and talk about 2015 Gauss Contest Grade 7 Part B. Question 11. At Gaussville School, a total of 480 students voted for their favorite subject. The results are summarized in the pie chart shown. How many students voted for math? So we have a total of 480 students. And among the 480 students, we have 40% of those students voting for math. So we times 40% to the 480, and we will have 190 as a result. Option B. Question 12. A piece of paper is folded in half, creating two layers of paper. So what does this mean? This means if you have a paper, we fold it in half, it will give us something like this. So we have two layers. The paper is then folded in half again. This is continuing until the paper has been folded in half, a total of 5 times. The total number of layers of paper in the folded sheet is. So we can look at a few examples and we can get a pattern. So if we have a paper right here, we fold it in half one time, it will create 2 layers. If we fold it 2 times, for each of the 2 layers that we have right here, we will create 2 for each. So we have 4 layers. If we fold it another time, each of the 4 layers will be divided into 2 halves again, so we would have 8. So we can see that if we fold it one time, the number of layers we have is 2 to the power of 1. If we fold it 2 times, the number of layers we have is 2 squared. If we fold it 3 times, the number of layers we have would be 2 to the power of 3. So we can see that these numbers are equal, they are correlated. So if we fold it 5 times, the number of layers would be 2 to the power of 5, which is 32. Question 13. How many even whole numbers between 1 and 99 are multiples of 5? So we know that if we have a multiple of 5, the number will end either in 0 or 5. And since this whole number is even, we do not want this 5 because any number that ends in 5 would be odd. So this question simply transforms into another question that asks us, what kind of whole numbers are there between 1 and 90 that ends in 0? So they are 10, 20, 30, 40, 50, 60, 70, 80, and 90. So we have 9. Option C would be correct. Question 14. In the 3 times 3 table shown, the numbers 1, 2, 3 are placed so that each number occurs only once in each row and only once in each column as well. So the value of x plus y is. So we can see that we have a x in the middle, the y in the right bottom slot, and we have a 1 and 3 placed. So this seems like a simplified Sudoku question. So if we go starting from this row, we have a 3 in this row. So we must place in 1 and a 2. So we can start by placing a 1. So we have 2 possible slots. We can put 1 here and 1 here. However, since there's already a 1 in this column, so it wouldn't be another 1 in the same column. So the only possible slot for the 1 would be in the middle, which is where x is. And since we have 1, 2, 3 on each row, so in this middle row, we will also have 1, 2, and 3. Now we look at this column. We have a 1, 2, so we must have a 3 in this column because there's definitely 1, 2, 3 in any columns. So we can see that x would be 1 and y would be 3. So x plus y is equal to 1 plus 3 is equal to 4. Option E would be correct. Question 15. In the rectangle shown, the area of the shaded region is, so we can see that this shaded area is a trapezoidal uh, shape. So we can figure out the top side of this trapezoid, which would be, since we have a symbol right here, that means if this length is 2 centimeter, this length would also be 2 centimeters. So the top length of the trapezoid, which is this length, will be 12 minus 2 times 2, because this is 2 centimeter and this is also 2 centimeter, which will give us a 8 centimeter. And based on the formula of calculating area of a trapezoid, it's the top side plus the bottom side times the height times 1/2, which is 20 times 5 times 1/2, which is 50 centimeters squared. Option E would be correct. Question 16. You have exactly $440 in quarters, dimes, and nickels. You have the same number of each type of coin. How many dimes do you have? So if we have an equal amount of each type of coins, we can set this number as x. So this total amount of 440 cents would be equal to x 25 cents plus x coins of dimes, which is 10 cents, plus x coins of nickels, which is 5 cents, which will give us an equation which is like 440 cents is equal to 25x plus 10x plus 5x, which is 40x. So x is equal to 11. And this shows us how many coins we have for each type, which includes dimes. So we would have 11 dimes. Question 17. One corner of a cube is cut off, creating a new triangular face as shown. How many edges does this new solid have? So if we trace the other side of the cube out, it will look something like this. And we simply can just count it from the bottom. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. We have 15 edges in this cube. Don't miss any edges, and we will get the correct answer. Question 18. In the graph shown, which of the following represents the image of the line segment PQ after a reflection across the x-axis? So we can see that the PQ is right here, and if we have something here and we want to reflect it over a line, which is the x-axis, and the x-axis is this line, this horizontal middle line right here. So you want to reflect over that line, we would get some sort of this shape. And we will see that the only line segment in this graph resembles this shape underneath this x-axis would be TU. So this would be symmetrical to this over the x-axis, over the horizontal line. So line segment TU would be the correct reflection. Question 19. When expressed as a repeating decimal, the fraction 1/7 is written as 0.142857142857. The 6 digits 142857 continue to repeat. The digit in the third position to the right of the decimal point is 2. In which one of the following positions to the right of the decimal point will there also be a 2? So we can see that for each 6 digits, it's a repeating group. So if we use these decimal numbers divided by 6 to see how many of these repeating groups are there in the decimal of this fraction, and we will get some remainder, and this remainder would be the location that we're looking for right here. For example, for option A, if we use 119 divided by 6, we will get 19 remainder 5. So this tells us that if we starting from this decimal point, go all the way down to the 1/19th decimal, we will have 19 complete repeating group, 1, 4, 2, 8, 5, 7 there. And we will have 5 remaining digits, which are 1, 4, 2, 8, 5. So the 1/19th digit would be 5. So we can repeat that procedure. If we use 121 divided by 6, we will get 20 remainder 1, which tells us that the 121st digit would be the 1 right here. Because in 121 decimal places, there are 20 complete repeating decimal groups of 1, 4, 2, 8, 5, 7. And we have a remaining 1 digit right after the 20 complete sets of digits, which is the first digit in the repeating group. If we use option C, 123 divided by 6, we will have 20 remaining 3. So we would have, again, 20 complete sets of the 6 repeating digits with the 3 remaining digits after that 20 complete sets, which would be the third digit in the repeating group, which is 2. And we're exactly looking for 2. So option C would be correct. Question 20. In a triangle, if the measure of one of the triangles is 45 degrees, the measures of the other 2 angles in the triangle are in the ratio 4 to 5. What is the measure of the largest angle in the triangle? So as we know that all the angles in a triangle sums up to 180 degrees. So if one of the angles 45, the other 2 would sum up to a 180 degree minus 45 degree, which is 135 degree. And those 2 angles are in the ratio 4 to 5, so we can set them as 4x and 5x, and these 2 angles sum up to 135, which means 9x is equal to 135, and x is 135 divided by 9 is 15. And we're looking for the largest angle. So as we know that one of the angle is 45 degree, the next angle would be 4x, as we set it to be, which is 4 times 15, 60 degree. And next is 5x, which is 5 times 15, which is 75 degree. So the largest angle in this triangle would be 75 degree, and option C would be correct. And that's all for part B of 2015 Gauss Contest Grade 7. Thank you for watching, and come back for part C.